This video will give you an overview of the standard calculation methods for the reduction index with airborne sound and the impact level with impact sound and how they are influenced by the thickness of floor and walls as well as floor covering. Flanking transmission is a phenomenon related to acoustic comfort in buildings. By emitting sound in the sending room, it is transmitted through the floor and the walls that connect the sending room with the receiving room. Since the walls and the floor are in contact, waves are propagated from the wall to the floor and from the floor to the wall. The impact of the flanking transmission is depending on the used materials, junctions, and geometry of the building. To study the flanking transmission in a construction, two possible methods can be applied. First, the measurements can be accomplished on site if the construction is already built. In that case, a source in the sending room emits sound, and the sound pressure level over the frequency is measured in the receiving room. Second, the same measurement can be done in a laboratory. Here the sound pressure level is studied for different prototypes of wall. Afterwards, a room model can be put up combining different types of geometry of wall using the data from the laboratory measurements. Often it is important to get the first impression of how a structurally acoustically behaves before it's constructed. This will save cost and show general limits in terms of design right from the beginning. Both the sound pressure level from the measurements on site and the measurements in the laboratory can be introduced to standard calculations for impact sound pressure level and reduction index for airborne sound. The idea of calculation the reduction index respectively the impact level is to express the performance of a construction in one value. This makes it more easy to compare with other buildings and classify the buildings due to standards. We start with the airborne sound method.
As mentioned before, to calculate the reduction index for airborne sound, one can study the behavior of every single room element in a laboratory first, and calculate a reduction index for every single wall, following international standards. By having this input data, we can take a closer look on the wave propagation through the construction. The wave can propagate through the flanks of the room and then the floor. It can first go through the flanks and then the floor, to the floor and then the flanks, just through the flanks, or directly through the floor. The formula to calculate the flanking reduction index for every single wall takes into account the path that the wave is taking, a vibration index Kij depending on the junction and on the material properties of the construction, and the dimensions of the floor where the sound goes directly through. Different junctions influence the reduction index in different ways. In the picture you can see the so-called T-junction on both sides. After having all flanking reduction indexes together, they are summed up in one big equation that will give the final apparent sound reduction index for the whole construction. And always remember, the higher the reduction index, the lower the effect of flanking transmission. Impact sound measurement. A very simplified model from the standards can be taken to calculate the impact sound pressure level. The impact of the floor basically just depends on the mass per unit area of the material. Usually the floor has a covering which has to be taken into account. Its reduction of impact sound pressure level can be taken from a graph in the standards. To do this, you need to know some material properties of the covering. The dynamic stiffness and the mass per unit area are needed to get the final reduction of impact from the graph. The last term that completes the calculations is the correction factor K. It is also taken from the standards. Knowing the mass per unit area of the separating floor and the mass per unit area of the wall surrounding the floor in the lower room, the K value can be taken from a table. It is important to keep in mind that for impact sound, a low impact sound pressure level in the receiving room means that only little sound from the sending room reaches the receiving room. The lower the impact, the better.
We studied the impact of the thickness of the wall and floors in a room constructed in concrete. The floor is ranging from 150 to 250 millimeters, and for the walls from 100 and 200 millimeters. We can see that in the upper table, the sound reduction level increases with the thicker flooring and walls. For the impact sound, it decreases with thicker floor and walls as well. This is not surprising because a thick and dense material impedes the propagation of sound pressure wave. Overall, a high reduction level and a low impact level is desirable. To achieve a more realistic value for the impact and airborne sound levels, a penalty factor is applied. This is mostly common in Sweden due to the fact that light construction material, such as wood, is frequently used. The light construction does not resist the lower frequencies as good as the higher ones, which means that an A-classified building might still affect an acoustic comfort in a negative way. By adding this penalty factor, a more accurate value of the sound insulation quality is determined. Considering a penalty might become more important in the future if a use of light construction material increase worldwide. The new results show that the values for both airborne and impact sound are worse. In case it's impossible to achieve the necessary classification, some improvements can be done. One way is to change the covering on the floor depending on the problem of the construction. Extra in the walls could be installed. Mostly this is a big problem because the construction is already set, which limits the possibilities of installation. If the building is not yet built, decoupling is a very effective sound improver. This means you separate the construction elements with some rubber material to access a minor vibration and sound propagations. The more elements that are separated with rubber material, the better the sound reduction will be.
To remember, thicker wall and thicker floor is always good for sound reduction. If you can choose, make a thicker floor. Of course, you have to fulfill the regulations defined by law as a basic. Furthermore, you can improve the construction with better junctions, for example. This is a question of money, which means that sometimes good acoustic comfort is ignored, even if it's very important.